Okay, so this is Adventures in Discworld. Obligatory waffle about me first. I'm Matt Smith. You might know me from the internet as Huxley Pig. My background is in computer science and software engineering, and I thought that's what I wanted to do when I was young until I actually did it. And sitting in a pod for 8 hours a day doing nothing but programming in COBOL wasn't fun. So I changed careers, became a locksmith, and that led to tool making. This paradise. This is my workshop, believe it or not. It's my cellar. It's a little shoebox. I hope to be moving out of here soon, but this is where all the magic happens. I like to look for what I call physical ODAs, so it's what it sounds like. It's an undisclosed vulnerability in a physical locking system. And I specialise in disk detainer locks, which comes from my Abloy classic obsession going back maybe 9 years now. But that's not all I do. I don't just work with disk detainers. I don't want people to think I'm a one-trick pony. So like I say, my reasons for getting into lockpicking probably weren't entirely virtuous. I knew about lockpicking from the Jolly Roger cookbook. Does anyone remember that? Going back to the 90s, it was a pirate Amiga publication, and it was generally full of nonsense. It was like snorting nutmeg is going to get you high, or smoking dried banana peel pith will get you high. And we tried all that and it was all rubbish. But there was the odd nugget of information in there, and one of those was lockpicking. So I just sort of knew what to do. And in particular, I used to enjoy liberating this from these. And I was pretty good at it too. And so good that I thought maybe there could be a career in this, a legitimate career in this. But I earn less money now than I did then. I'm much poorer than I was then. But crime doesn't pay. Okay, so I don't know how we all are with disk detainer locks, so I'm going to start at the beginning. So it's pretty much anything that uses disks to rotate rather than pins that go up and down or wafers that go up and down. This is a typical disk detainer here. The most obvious ones are Abloy, Abus. This is an IFAM, Baton, do a range of disk detainers, they're quite good. And a million generic Chinese disk detainers, which are generally useless. And I've got a little animation, which I didn't make. Thanks to Skylar Town for this, actually. We can probably skip a bit of this. So these are disks. You've got gates around the outside. You've got the false gates and true gates. And these will rotate round to a particular position as determined by the rotational cuts on the key. Now there'll always be an outer shell here, and you'll have a sidebar at the top. And that sidebar locks the inner shell to the outer shell. So this is a lock in the locked state. And then when all of the disks line up, all of the gates form a channel underneath the sidebar, which allows it to go inwardsly down. And then the lock can open. So this is the disk stack. I thought this animation was quicker. Okay, so you'll see the key turning the gates around to where they need to be now. Okay, so you see them coming around, slowly lining up. And when that channel falls underneath the sidebar falls in, the lock opens. These are Abloy Classic disks, and you've got 6 different positional cuts. So it's rotation base, this is the key. Again, you've got different angles which correspond to the different gates. Now, an assembled disk detainer pack always has washers in between each disk. Now, the point of this is so that when one disk moves, it doesn't move its neighbour through friction. So it decouples the disks. It's an Abloy Classic, this is an Abloy Sentry, in case you were wondering. And quite interesting drill protection here. You don't get this very often. I've only ever seen this once. It's like a ceramic disc that sits at the front of the pack and protects the sidebar from being drilled. And they pretty much fall into three categories: Abloy, Abus, and everything else. So this is like an everything else lock. It's just rectangular. Abus also look very similar to this. And this is an Abloy Classic on the left. And the profile on the right, you can see it's pretty much a Classic with extra little bits. This is a Protec. Now you can tell the difference between a Protec 1 and 2 because these little teeth here, they're staggered on Protec 1, and on Protec 2 they'll always be opposite each other. This is a century stroke exec, so you can tell this because one of the corners will always be square. And this covers pretty much every other Abloy: disc lock, Nivelle, Cento. It's like the Protec, but you've got a wider space here, and the corners are all rounded. Right, so let's have a look at some ways we can destroy disc detainers, and there are lots. You can mill the face off. You can drill for the sidebar. This isn't the official name. I call it the gut poop. It's knocking all the discs out the back. We'll have a look at that. You can put a blank in and shear the shell, or try and make your own gates just through pressure. Or you can heat a blank or just blast heat into there. We'll cover all these in more detail. You can pop the face off the front, or you can drill for the retaining screw on padlocks. So this is the face mill. It applies to camlocks and Euros. Now Wendt from Germany sell a special end mill that is really good for this, but you can get, it's just a circular cutter. You can get them from China, just a carbide cutter. We're going to have a look at this in action. This is devastating. This is actually Abloy's hardened shell. So this isn't just standard steel, this is hardened steel. This is like their fix for this attack. And that's it. That, you can just pull the guts out. You'll see it again there. So you're just removing metal from the face, and you'll get a screwdriver in a second and just pull everything out, and then the lock will just open. Abloy's answer to this is they say, well, you should put your lock behind a shield, which I think is a bit of a cop-out, really. Put anti-drill protection in there. That's it, it's as simple as that. And like I say, you can do this on cam locks as well, exactly the same. This is drilling for the sidebar. So one of the problems with a lot of disc detainers is they have round sidebars like this. Now the better ones have L-shaped sidebars, so if you drill a hole in the front and you try and pull it out, the little L-shaped part of the back catches and you can't do that. But pretty much every Abloy Classic I've ever seen, most Abloy Profile, and the newer lock, the Century, one of the current locks, they all use this straight sidebar. So this attack's applicable to all of these. And for an Abloy, the drill spot is always directly opposite the Y of Abloy. Now, there was that shield, that plate I showed you earlier, that's designed to protect against this, or you can actually get hardened steel shells. This is a hardened steel shell. And if you just use a 2mm carbide cutter, it'll rip through it. And then obviously once you pull the sidebar out, you can just turn it with a key or a screwdriver or whatever. Forcing with a hardened blank. So the idea here is either to shear that inner shell. So if you break that inner shell, the sidebar's got nothing to hit against anymore, so it'll just spin. Or the other thing you can do is try and make your own gates, because the sidebars are always made from hardened steel, and the discs are always brass, most of the time. And so if you put enough torque on that, the hardened steel is going to eat into the brass and dig its own gates, and the lock will open. And this applies to every type of lock. This is the gut poop. I was going to show a video of this, but the only one I could find was Bosnian bills. And to be honest, hell's going to freeze over before I use that video. So it applies specifically to cam locks. And the problem is this copper washer at the back. And every Abloy cam lock on the planet has this copper washer, except for one. There is one specific model which has a front loading pack. But you can pull it up front anyway. But that's not the point. Even Protec 2 cam locks are vulnerable to this. The IFAM has mitigated this by using, I don't know if you can see here, it's like a keyring type piece of metal, and that makes it's steel and it's wider, and it's a lot harder to do the attack on this. And this is a special little tool. It's a gear puller, but it's a little gear puller. And the teeth there eat in around the side of the cam lock, and you just wind it in and it slowly pushes and pushes. So the point is, you don't have to hit it hard with a hammer. You can do it silently with something like this. A face pop. Okay, I've got another video of this. This is specifically to padlocks. Pretty much every cheap Chinese padlock you can do this with. Some of them you need to put more strength on than others. But the problem is the way they've loaded the pack. So it's loaded from the front, and then you've got a cap which has a sprung circlip in, and it's machine pressed into the lock body. But if you put enough torque, or well, enough pressure on it, you can pop that face off. Or you can use a slam hammer. You know what these are? Like dent pullers. Yeah, you know, like it's basically a rod with a weighted handle on. And you just pull the weighted handle back, and you need to put a screw in there, obviously. Or you can use plug pullers, which is exactly the same. Like a plug puller designed for pin tumblers. So to get around this, you can either top load the stack from where the shackle is, or what Abloy and Abus and a lot of the better locks do, they have screw-on caps, which has a screw. It screws in, and then you've got like another bolt which locks it in place. And this guy makes a real meal of this till we get to about here. Okay, so you can see he's got the screwdriver in the face, and he's just levering. There we go. The face pops off, and then you can just empty the pack, and nothing's stopping it from opening at that point. Very quick, very easy. Okay. Heath. This is a less common attack. So what I was talking about earlier with using a hardened blank and sort of making your own gates. So ask any 9/11 conspiracy theorist and they'll say steel can't melt at whatever bloody temperature it is. But metals get weaker when they get hot. That's the point. Some of the cheaper ones have plastic shells, which will just melt pretty much instantly as soon as you put any sort of heat into the lock. But you can use an oxyacetylene torch. It's perfect for this little jeweler's torch, because you can control the flame, and you can get it right in the keyway. And it doesn't take very long. As soon as you apply heat to it, and apply rotary tension, the sidebar will just push down into the soft brass and make its own gate again, and the lock will open. This is another destructive way you can do. So most Abloy have screws that keep the face in place, and you can drill for that screw, and once that screw's gone you can just unscrew the face again. Abloys also have a nice little hole on the side. Now there's a shackle behind it, but it acts as a nice pilot hole if you want to try and drill through the shackle. That's not easy. You have to stop the shackle from bouncing around. But if you can do that, then it's pretty easy to disassemble the lock. Or you can just go for the screw directly. You have to know your lock though, because Abus and Abloy, different padlocks, have this screw in different places. Okay, this is the more interesting bit, this NDE. So you can pick it. I've got a tool that I call the silver bullet, which picks most disc detainers. This is a less well-known trick, wire decoding. So the idea is with this, you'll like get a piece of wire and you'll travel up between the discs and feel for the gate. And as soon as you hit the gate, you'll have a rotational position. You can impression disc detainers. Doing it in the traditional way with a blank isn't easy unless you use a different technique. I'm not going to be covering impressioning today, or self-impressioning, but the same goes for self-impressioning and impressioning. If you use a rotational technique rather than a wiggling blank technique, then you can impression them no problem. And I guess you can bypass some of them. I've not found any yet, but they've got to be out there. So how do you pick a disc detainer? The idea is the key will always have a zero cut, and that's what drives the lock. And you need to know where this zero cut lives. Now luckily, it's pretty much always at the rear or the front. Lockmakers have sort of cottoned on to people tensioning from the front, so they've been swapping the position of the zero disc. But the theory is, you tension the zero disc, and then like picking any other lock, you look for the binder, move it until it stops binding, repeat until the lock opens. One of the things that makes it difficult is the picking tip. The picking tip needs to be able to manoeuvre between the pack. So if you've moved one disc around 90 degrees and you've got another one next to it that hasn't moved at all, your pick has to slip into the gap between the discs where the washer lives, move around and then move on to the next disc. And often you'll get false gates, and so once you've got everything into either a real gate or a false gate, you'll then go through the pack and check for the false gates. And once you've got all those into the real gates, the lock will open. Now, before I made my tool, this was pretty much the only disc detainer pick you could get. And to be honest, they're awful. I think this one, it's like £5 I paid for mine. It's super cheap. And you get what you pay for. It's a pathetic tool, really. You can make them a little bit better, but you'll never be able to make it into a true pick. This is my silver bullet, which tensions from the rear. I designed it originally to pick Abloy disc lock, which it does pick, but it also picks every other non-Abloy disc detainer I've seen so far, so it's pretty universal. Or you could use a 3-in-1. So the idea is with this, the tensioner is in the middle here, and you've got a picking tip on either side. So if the zero disc is not at the front and not at the back, somewhere in the middle, you can always pick up on it, and you've also got a picking tip either side with which to manipulate the discs. The top one is a profile 3-in-1, so you can see the shaft here is 3mm and this is 2mm, so I've squashed it into a smaller space. It was horrible to make. Or another option is an 8-in-1. So has anyone seen the Tibby picks, the Caterpillar Tibby picks? You've got all these sections and they're concentric tubes, and each one has its own dedicated handle. So it's like, I say it's like having your fingers inside the lock. You can very quickly feel what every disc inside the lock is doing. Now, what makes picking them difficult? So we get false gates. A lot of blocks have blocking mechanisms. So Abloy Protec, Abus X+. Profiling's a pain from a tool making perspective. So the teeth here, they choke off the space that you have to get something inside of the lock. But if you're in the field, one pretty cool trick is just to get a little file and just shave those little teeth away. It only takes a second, and then you've got as much room as you like to get your tools in. They make the front discs spin freely, so if you try and tension from the front, it won't work, it'll just spin. You'll be there all day. And those cheapo Chinese picks I showed, they'll only work on the cheap Chinese locks, believe it or not. And only my tool copes with everything. So far. So, decoding. This is a fundamental flaw in disc detainer design. The pack can't be under tension. The discs have to have a certain amount of freedom to move. If they're squashed in, then the key will wear more, and it makes the lock sticky, and they need to have a certain amount of slop. Like every lock, there has to be a certain amount of tolerance for it to operate smoothly. And every disc detainer I've ever seen is vulnerable to this, except for Protec 2. We'll cover this in a bit. You have to know your lock, because the gate positions change around 360 degrees. So you have to do your homework, but once you know where the gates live in the lock you're attacking, this works great. It's not my preferred option, but it is a pretty cool attack. So the tool looks something like this. So it gets introduced into the lock, slides up between the discs, and this little tuft on the end here, that feels for the gate, and you can feel it click into the gate, and then you can get a rotational reading, and you know what the key should look like once you've done that for every disc. But it still doesn't open the lock. It'll tell you what the key should look like, but you still need to cut a blank or dial in the combination. So it helps, but it won't open the lock for you. Okay, let's have a look at some particular locks. So this is Abus Plus. It started off as the Abus Granite, years ago. And Abus are really good at improving and updating their locks. The Abus Granite went through lots of revisions, then it's now the Abus Plus. They still do a Granite, but Abus Plus is like their best lock now. The full skates are the best thing about this lock, but they also feature butterfly discs, which are these things here. They put these in the front and the rear of the pack now for every lock, so that if you try and tension from the front or the rear, it'll rotate too far and push the sidebar up. And the idea is it stops you tensioning from the rear or the front. The actual driver disc for Abus Plus now is randomised. It's always somewhere in the middle. You won't know before you attack the lock where it's going to be. It also uses a special anti-pick system. Now, in reality, this is completely useless. It does nothing. But the principle sounds good. So what they've done is, remember what I said earlier about the pack not being under tension? Well, they've done this. They've put the pack under a little bit of spring tension on purpose. And they've made it so that the washers wobble a little. And the idea is if you move one disc, all the other discs move as well. So if you think about this, if you're trying to pick the lock, you'll move one disc and all the other discs will move, and then you'll think that's correct, and you'll move on to another disc and it'll move the one you just moved. And in theory, this makes picking the lock completely impossible. But this was obviously not done by a lockpicker or wasn't tested. Because when you tension a lock, you've got the sidebar pushing down into the pack, and the amount of pressure from the sidebar pushing down into the pack is vastly greater than the amount of spring pressure that they've put on the lock. So in reality, it does nothing. When you're picking the lock, it does absolutely nothing. Might as well not be there. Oh, and the other amazing thing about Abus Plus, I don't know if you can see it here, but the key has a slight profile on it. And yet I've never seen a profile disc on any Abus Plus ever. And like I said earlier, making profiles makes it harder to pick, makes tool making harder at least. I guess there must be a reason for it, but I can't think what it is. So how do we pick this lock that's got the randomised zero disc? There's actually quite a few options. You can tension from the front or rear still and just pretend that the butterfly disc is a 0. Obviously this won't open the lock, but it will put the core under tension. But it'll really dampen feedback. So if you try and go up and down through the pack, you'll be able to feel gates, but it sort of ruins it. You can do it, but it's not much fun. But the theory is, you'll go up and down through the pack, you'll set the gates to where you think they should be, and then you'll find the actual 0 with your picking tip and rotate your tensioner back, and then the lock should open. But this isn't easy to pull off for an unknown lock. So another option is to don't use a tensioner at all. Just use 2 picking tips, like here. So you pick any random disc with one of the picking tips, put it under tension, and then use the other picking tip to go in and out of the pack. And if you're not getting any feedback, you know you've probably got the wrong disc. So you'll move on to the next disc. And if you want to swap tension, you'll just swap tension from one picking tip to the other picking tip. But again, this isn't very easy to do. It's easier than option 1, but the easiest is to use the 3-in-1 I showed earlier, or the 8-in-1. That's the best option for Abus Plus, by far and away. Or there are other ways that you can tension the plug as well. You can get creative with your tensioning. So maybe you can grab the plug in some way. So you're not actually using the discs to tension it at all. You're just directly tensioning that inner plug. And that works. This is Abus X Plus. This is meant to be their improvement on Abus Plus. I've only ever seen this on bike locks. And it features a blocking system. So if you can see here, you've got like a little button there and a little button there. And if you try and manipulate this lock, the discs won't move. You have to have these buttons pushed in, and that frees the pack up for the key to move. But if you try and put a rear tension pick in here, it'll free the discs up, but they've got this separate section at the back which will just spin. So you'll free the pack, but you won't put the lock under tension, so it ruins it. You can see it's got quite a unique key tip. It's like arrow shaped, and that's to push these little teeth back. And again, it's got a profile key, no profile disc. What's all that about? Why do that? And you get it on bike locks. So how do we pick these? You can use a rear tension tool that mimics the key, which is what my tool does. So you can see you've got these gradual slopes to push those teeth out. But to get around that free spinning rear section, it's quite long, and it bridges the gap between the two sections, so it pushes the teeth out and keeps both sections coupled. This is how the key works. Or another way you can do it is to bypass the blocker and tension from the front with like any cheap Chinese tool you can do this with. So you could get like a pick and just put the pick in the keyway, push the button down, and then as soon as you move the discs, you're away, you can pick. This was one of my obsessions, Abloy Classic. So what makes Abloy Classic hard to pick? There are quite a few things, but the main thing is something I call problem 50. This is problem 50. You've got 90 degrees of movement, but in pretty much every Abloy Classic lock you'll ever see, you'll have a 5 and a 0 disc in the pack, which is what we've got here. Now, you need 90 degrees of movement for your pick to work, right? And you might say, well, okay, I can see 90 degrees here, what's the problem? The problem is your pick arm, this part here, has to exist somewhere. So if you put it, say, here, after you've moved it 90 degrees, you're disturbing this disc here. If you put it here, after 90 degrees, you're disturbing this disc here. And so, theoretically, it makes it impossible to pick the lock. You also get anti-pick discs, which are these things here. Abloy Classic hasn't always had these. These were introduced after, what's his name? Seppi Tervonen. He was a Finnish sex pest, and he was breaking into young ladies' houses, hiding under the bed, waiting for them to come home, and often creeping out from under the bed and attacking them. A pretty scary guy. He got caught, and the police didn't believe that he could pick Abloy Classic, because this was like the first recorded time it had happened. And so Abloy introduced these anti-pick discs to stop his Vempele, his tool, from working. Vempele is Finnish for thingamajig, or what you call it, you know, one of those type of words. They also put a free spinning front disc at the front, because his tool tensioned from the front disc. So since his picking of the lock and these changes, there was no recorded picking of an Abloy Classic until I did it. I've since found out that wasn't actually the case. People have been picking them in secret, like, you know, government agencies, that sort of thing, pretty much forever. And you've got false gates. The false gates are really good on Abloys. So how do we get around these problems? So problem 50, you can see here that if the sidebar is overhanging one of the gates by 50% or more, when you tension the lock, what that means is you're pushing the sidebar down. And so that sidebar will automatically fall into the gate and bring the disc round automatically, so you don't have to touch it. Just tensioning the lock will do this. Which means you've got maybe 6 degrees in either direction that you can dislodge the discs and get away with. And that 6 degrees is enough to just about get a pick arm in. The anti-pick discs, you need a full profile tool, so you don't ever go into that middle space. You work around the edge like the key. You tension from the rear to get around the spinning front disc problem. And once you've done that, picking the lock becomes possible. Not easy, it's still not easy, and you still need a specific tool, but it becomes possible. I actually wrote an essay about this. It's really boring. You can ask me, I can gladly give you the address for it. I don't think it's boring, but I think a lot of people would. But if you want to read it, just ask me about it. Okay, Abloy Protec. This is the one that we want to hear about, right? Abloy got really clever with their disc design. After Classic and Profile, they started making it so that the key would turn the discs, but in order to get the discs back to the reset position, the key didn't do this. It was via another mechanism, either by return bars around the edge or by like a disc steer. It's like a bar that pushes them back round. Now this makes picking difficult because you can only move the discs in one direction. You can't wiggle to check if you're in a false gate or a real gate. You can't bring the disc back to 0 if you think you've gone too far. It makes picking it really difficult. They also put disc controller arms in there, which acts like a curtain. So you've got these 2 arms that exist within the lock, and that chokes off the space that you've got for tools. The false gates on Abloy Protec as well are particularly wicked. They've got false gates in every single position for every disc. But the thing that makes Abloy Protec particularly difficult is the disc blocking system. One sec, where are my pictures? Yeah. Okay, we can use these. So this is the disc blocking system here. You've got 2 bars, and when the bars come together, the one bar falls down under the other one and goes into these little teeth here. And that blocks the discs from rotating. So if you try and tension the lock, the discs are locked down. You can't manipulate them. Well, that's the idea anyway. So if you want to pick an Abloy Protec, your tool, it needs to be able to cope with this one-way movement of the discs. Or maybe you need to get some extra information out of the lock, telling you what's happening with the discs as you're moving them in this one direction. You can move the discs back again from within the keyway, but it's really difficult. You need a really stupidly shaped piece of wire, and it's really difficult to do. It's not practical, not in the field. And if you couldn't bypass this blocking system, it'd be pretty much impossible to pick. But luckily, we can bypass the blocking system. Now, it's not like once you bypass the blocking system, you're going to pick the lock. It's still a very difficult lock to pick. But once you bypass the blocking system, it becomes possible, at least. So here's the first bypass, the Protec one. Lock was round the back. So the idea is here, you see this little gap here? At the top of the plug, you can see the daylight shining through it. You fish a piece of wire through the keyway, up here, and then between the blocking discs, and you can see this is the lock under tension on the right. Once those two bars come together, the wire stops it from going down into the grooves, so it doesn't block anymore. Everything's in the correct position for the lock to open, but no blocking system. They fixed this on Protec 2 by filling this hole. So they've got like an anti-wear system disc now, and it just lives in the space where this hole used to live. So you can no longer get up there and around the back. This one's a slight variation on that. You can get a wire through the pack. So it's very similar to the last one we saw. Only with Protec 1, they left quite a lot of slop in the pack, which means it was really easy for you to get a wire up between the discs, either to decode the lock or going in the other direction and bypassing the disc blocking system. And again, same as before, the wire stops the bars from sliding under each other. They come together, but they don't block. I prefer this to the first option because the first option, your manipulation tool has to cope with a wire running all the way through the lock. Whereas with this, you can put the wire right at the front of the lock. It means you've got more space for your manipulation tool. And Protec 2 fixed this by getting rid of a lot of the slop within the pack. And they did it by clipping the face on. Hold on. Is that the same one? Yeah. Okay, so this is going through the pack. You can see here it's right near the front. And same sort of thing when the bars come together. It doesn't block. So at this point you can impression or pick the lock. It makes it possible to do it. Now this is my favourite. All Protec 1 padlocks had a profile plate on the front which didn't spin freely. You know, we've been here before, right? And not only did it not spin freely and allow you to tension the lock, it also completely bypassed the disc blocking system. So you could just tension straight from the front and then get in and manipulate the discs. How this would work is you'd move the discs around to 90 degrees so they were almost touching, and then you'd tension from that front plate. This makes really good tool making options because that front plate is accessible really easily. And so you've got a load of space behind it there that you can do what you like with. And it's the same old mistakes I see cropping up time and time again with Abloy. This free spinning front disc thing. They've made this mistake with Sentry as well. They've sort of put a sticking plaster on it now. They've sort of fixed it. But it's same old things. And they fixed it, believe it or not, by making it spin freely. Now Protec 2, this blocking system, bypasses. Now they do exist. All the ones I've spoke about for Protec 1 have been fixed or mitigated, but they still exist in Protec 2. Now I'm not going to be covering the Protec 2 ones because it's their current lock, but hopefully what I've just gone through should give you some idea of what to do. And some of the problems on Protec 2 can't be fixed. It's intrinsic to the design of the lock. Some of the bypasses are applicable to both systems, some are only applicable to one. Some are harder to pull off than others, some leave more marks than others. I've got 6 bypasses for Protec 2 at the moment, 2 of which we've worked out this weekend, and so this list's, it's always growing. Yeah, the list for Protec 1's up to 13 now in total. Some leave more forensic marks than others, and yeah, some of them can't be fixed. But like I said, I'm not going to be going through the Protec 2 ones. The vulnerabilities are out there. If you want to find how to get through Protec 2, just study the lock. There's loads of different ways that you can look at physical locking systems. And these are pretty complicated locks, and more complexity means you've got more avenues to attack. Don't be intimidated by exotic mechanisms. This is something I see a lot. This is one of the reasons I think things like Bilock and Abloy have led a pretty charmed life. People see the locks, and magnetic locks anyway, they'll see them and go, oh, these are complicated locks, I'll just stick to pin tumblers. And so people won't look at them and attack them. Don't be put off by them. They were designed by people. They were designed by people like you and me, no smarter than you or I. They were tested by people no smarter than you or I. They will have missed things. And even if they're happy with their testing, no lockmaker can ever know every attack that exists out there. And so they can never make it 100% secure. Except I've designed a lock that mitigates everything that I've just gone through. So in my head it's 100% secure, but I'm sure it isn't really. Researching detainers has been like a really rich vein for me. I've learnt new picking techniques, I've learnt a new way of impressioning detainers, multiple decoding techniques. Detainers haven't been around that long, so they're relatively immature compared to like lever locks and pin tumbler locks. They've not had time to have had all these attacks found and mitigated against. So there's plenty of ways you can attack them still out there. And this also goes to pin tumblers too. Just because they've been around a long time doesn't mean every vulnerability has been found in them. There are still vulnerabilities in every type of lock out there. So just keep looking and you'll find them. That's it, we're done. Thank you. Any questions? Yes, mate.
How long did it take you to go through Protec 1?
How long did it take me to get through Protec 1? It's a good question. Like, Abloy Classic took me the best part of 6 years. But I guess I sort of cut my teeth with that. And as I moved my way up the Abloy food chain, by the time I got to Protec 1, I'd found my first DBS bypass after, I was about 2 weeks, I think. It wasn't long. But like, if you were just attacking it cold, then it'd be a big ask. You really have to work your way up to it. But about 2 weeks, I guess. Not too long. Yes, Ollie?
How long does it take you to attack a Protec 1?
Okay, from start to finish. So the question was, how long does it take to attack a Protec 1? Like, to open one, I guess you mean, yeah? An unknown lock from start to finish. My preferred method isn't anything I've gone through. My preferred method is to decode the lock in a different way. I use, well, I'm not going to say exactly what I use, but I use electronic help, let's say, okay? And using this device, I guess, worst case scenario, 2 minutes. Protec 2.
Protec
Yeah, 2. But the attacks on Protec 2 pretty much universally work on Protec 1. And so the tool I've made for Protec 2 will work on Protec 1 and Disc Lock and Novell. And
So Protec 2, 2 minutes?
yeah, Protec 2, 2 minutes. Protec 1, 2 minutes. It's about the same.
Do you have a demo or like video you can do?
Not right now, no. I'm keeping my powder dry on that for the moment. But you'll definitely see it one day, I promise you. Yes, mate.
Is your lock design patented, or are you going to sell it to someone?
Yeah, I'm currently in the process of trying to flog it, as it happens, yeah. I've not patented it now, but I've got registered design rights on most of the parts. which is actually a criminal offence to break, unlike breaking a patent. But yeah, hopefully I'll be able to flog it to someone. Yes, mate.
What's the, I mean, you said you've got some 0-day hunting in locks. How does the sort of responsible disclosure process go with Lockmakers versus, software vendors?
Okay, so the question is, if you find a vulnerability, how does the disclosure go with the Lockmakers? Okay, that varies wildly from Lockmaker to Lockmaker. I've been ignored, I've been threatened with suing. Some of them are great, some of them will work with you, some of them are happy to take your suggestions on board. I mean, I don't work for free, a lot of them want it for free, and so I won't do that. But yes, some of them are great, some of them are absolutely terrible. There's a whole spectrum of reactions you get, and I've had cease and desist orders and stupid things like that, It doesn't fix the problem. That's the terrible thing about that. Lockmakers that bury their heads in the sand, it keeps the vulnerabilities in the wild. That's the problem. And that doesn't help anyone.
So you're talking about locks only really being secure, or the lock designers sort of know about the attacks that they know about, therefore nothing's going to be 100% secure. Do you know if these manufacturers actually sort of find people who are sort of experts in the field of that lock and contract them in to try and break them or anything like that?
Okay, so the question is, do Lockmakers sort of employ consultants and that sort of thing to do vulnerability research? Yeah, I've done quite a few vulnerability reports now for various Lockmakers. And like I said, some of them are great, some of them are responsive, some of them are awful. Most of them have got their own testing in-house, but obviously they're only limited to what they know. And it makes a lot more sense to outsource it to people who know what they're doing. And yeah, I can't tell you who the companies are, but if you live in America, you'll have definitely used a lock that I've had a hand in improving. Yeah, it does happen. It's just not as common as I'd like.
Yeah, a couple of tool members started working for some.
Right. Okay. Yeah, it's good. They should embrace the community more than they do at the moment, I think. A lot of Lockmakers are pretty insular, and they just want to stick to their own testing teams and what they know. And sometimes you'll go to them with a vulnerability and they'll be like, no, rubbish, no. And they'll just ignore it. And you can put a YouTube video up and try and shame them, and they'll still pretend it doesn't exist. What can you do?
Yeah, oftentimes that's a perspective for a lock manufacturer. They have to build to a price point because they're selling to the consumer. So some attacks are really difficult to mitigate because they're a change that you take an entire different design using different materials, and so it's not that they completely ignore the community, but they've got to they're trying to put something out for price point that goes through the consumer. That's sometimes why there's some ignorance in it, because it just doesn't fit their pricing.
Right, okay, so you're saying sometimes it's just too expensive for them to fix certain things, and it's not practical.
Lock or a $50 lock, $100 lock.
Uh-huh.
To change all their tooling, it's going to cost $100,000.
Right, yeah.
So for the level that the security they're providing, it's just not worth it to reinvest to do that for that.
Well, we have to remember that Lockmakers exist to make money. They don't exist to... Well, okay, I guess they do exist to secure people's houses, but primarily they exist to make money. And so if you go to them with a problem that's going to bankrupt them, they're not going to fix it, are they? Doesn't make sense. That's it. I guess we're done.